Hello. Welcome to the stream. If you're new here, my name's Jared. I have been known on occasion to write Ruby code, and I run a consultancy where we build e-commerce websites using Rails and a platform called Solidus. Tonight, we are continuing our journey into the advent of code puzzles. We are now further than I usually get, but not further than I've ever gotten. I think I've gotten up to day 15 or something is the furthest I've ever done before I got distracted by the regular holiday happenings and fell off or got stuck on a puzzle and never came back to it. Our first 5 episodes, 5 days, we did TCR, test commit revert, where when I ran my tests, if they passed, my changes were committed, and if they failed, my uncommitted changes were thrown away. In the interest of focusing more on the puzzles themselves and their solutions, I have stopped doing that. So today we will continue with day 8. As with every day, I am working my way through a whiskey advent calendar. There we go. There's the beautiful color of today's. It is not what this says, but in fact, what this says, Laird of Fintry, just from Okanagan Spirits Craft Distillery here in BC. I have been to the Okanagan. I have not been to the Okanagan Spirits Craft Distillery, but hopefully one day when we are allowed to travel again, maybe I'll go. It is very smooth. Rosemary is one of my favorite flavors, so I did not pick that up on the nose, which is sad to me. I did get some of the sort of sweeter flavors though. The sausages I had for dinner had rosemary in them, and they were delicious though. Yesterday, we got stuck trying to make a tree when we didn't really need a tree, when we could just do a little recursion. But we got there. I think in under an hour. Certainly not our fastest, in fact our slowest, but our solution worked. We wrote a parser, parsed things out into sort of the naive data structure that I saw in the data. For part 1, we used this fancy transform1 class that we wrote with some tests to get the data into the shape we wanted, and then wrote a relatively simple recursive function to produce the result. Part 2, turns out we were able to just use the original data structure as it was. So as you can see, my part 2 is very simple. So yeah, that's where we're at. I don't know that I have anything else to say. I should really put my keyboard on Christmas colors. Maybe that's the important thing that we're all here for me to do. So is the green, should the alpha key area be green maybe? It's the like Christmasiest green I can do. And then maybe a slightly orangier red than that. Good. Got enough. If I can show that on stream. How's that? Come on. Yeah. Doesn't really reproduce the color perfectly, but we'll go Christmas colors here on out on the keyboard. Seems fitting. And sort of matches the vibe in here. Hello, Mamesy. Welcome back again. Mamesy is brewing up some apple cider, which I have on. I have a solid rumor that I trust that there's going to be some bourbon in it. Got 4.5 minutes before we get started. I should probably stop doing my intros 10 minutes in advance because 5 minutes is plenty, but here we are. Wasn't just gonna stare at a wall for 5 minutes. I should have been staring at the fire. Slowly working my way through Kent Beck's Extreme Programming Explained for the apparently second time. I do not remember reading it, but my Kindle tells me I have before. I certainly know I've read things about XP, but 1 or 2 ounces of bourbon. This is a hard decision. I mean, it really feels like it depends on how the stream's going. Let's say 1. Let's say 1. Moderation is the play, I think. All of the, so you can see that there's, you know, red and green lights behind me. This continues on onto my desk, so I have green bias lighting along the back of the desk. The lamps, one of the lamps is turned red, one of them is just on a regular color to keep the so I can read my notebook, honestly. Ba-ba. Now streamed 9 hours and 20 minutes on here. In the new year, I will be returning to doing regular Solidus streams. Those will be during the day, not in the evening. Hopefully some of our European friends will be able to attend those ones as well. I usually do them in the morning, though my morning schedule is fairly busy because we also work with European clients, so tend to have meetings there. But I'll try and block off some time so I can do some solid Solidus streams. We built a simple extension previously on the stream, and I imagine we'll find some cool other stuff to do. I have some work around our TaxJar extension that needs doing. Could do that on stream. Just sort of show how that works. We might build additional extensions. We might put together a store. Who knows? All right, minute and a half to go. As of probably either tomorrow or the next day, I will have an M1 MacBook Air, so I will be attempting to stream with it. We'll see how far we get. My environment that I'm actually coding in on here is not running on my local machine here. It's not running on my Mac. So we have some leeway there, shall we say. There is very little, as long as I can SSH out and OBS works, which I'm told it does, should be able to just do it. All right, well, final sip of whiskey before we get started. It's very nice. It's very nice. Very sweet. All right, let's get to it. Day 8, handheld halting. Your flight to the major airline hub reaches cruising altitude without incident. While you consider checking the in-flight menu for one of those drinks that come with a little umbrella, you are interrupted by the kid sitting next to you. Their handheld game console won't turn on. They ask if you can take a look. You narrow the problem down to a strange infinite loop in the boot code of the device. You should be able to fix it, but first you need to be able to run the code in isolation. Oh, are we building another VM here? The boot code is represented as a text file with one instruction per line of text. Each instruction consists of an operation, ACK, jump, or NOP, and an argument, a signed number like +4 or -20. ACK increases or decreases a single global variable called the accumulator by the value given in the argument. For example, ACK +7 would increase the accumulator by 7. The accumulator starts at 0. After an ACK instruction, the instruction immediately below it is executed next. Jump jumps to a new instruction relative to itself. The next instruction to execute is found using the argument as an offset from the jump instruction. For example, jump +2 would skip the next instruction, jump +1 would continue to the instruction immediately below it, and jump -20 would cause the instruction 20 lines above to be executed next. NOP stands for no operation. It does nothing. The instruction immediately below it is executed next. For example, consider the following program. Then it's going to demonstrate what we're supposed to do. One, two, three, 4, 5, 2, 3, or jump -4. -1, -2, -3, -4. How do we get? Oh, I see. 1, 2, 3. That's a jump. So we jump 1, 2, 3, 4. That's a accumulator. Then we jump 1, 2, 3, 4. That's an accumulator. Then we jump 1, 2, 3. Do 8. The first NOP +0 does nothing. Then the accumulator isn't okay. That's just the thing that I just stepped through. I think we can skip that paragraph. This is an infinite loop. With this sequence of jumps, the program will run forever. The moment the program tries to run any instruction a second time, you know it will never terminate. Right, because there's no. This isn't. we're not Turing complete here. Cool. Okay. These are fun puzzles. I like these. I kind of want to run this. Ooh, burning myself on my hot apple cider. Let's do something fun with this, though. So, I mean, this is just going to be a massive string of things. Sick. Let's get down to business. Day 8. Puzzle. Yeah, we're day 8. You know, days sort of blend together. It's difficult. And then we'll open day 8. Well, this is day 7. Day 8. This is still day 7. Did I? Sometimes. Did I run the command? Okay, I did not. Now, my first question is, does that 2i correctly? It does. Sweet. All right, let's set up our test. And we expect that to equal 5 or 4, 6, you know, any number really is fine. Well, let's do something fun here. This class machine struct new. I should probably parse this first. This is not how you write that. Just completely forget how to type. All right, let's start with parser. Or maybe we... Yeah, let's start with the parser. Yes, we can. We can test drive it, I guess. Lowered my seat. Uncomfortable. And sure, let's just use our sample input. But we're not going to expect it equals 5. We are going to expect that it equals an array. Each of these are going to be tuples. And we can, wow. Because of the load on my computer, there's like noticeable input, like very noticeable input latency. Not like Gary Bernhardt would complain about it, input latency, like anyone would complain about it, input latency. Here's hoping the old, oh, come on, fingers. The new MacBook Air handles that a little better. So it's gonna fail. All our tests are failing. Maybe for next time, I'm thinking we should make a parser as part of the template. So we'll split that into lines, and then we'll map those, and each line is going to be, so we'll say instruction number equals line split on space, and then we want to return instruction to symbol and number to I. Cool. we have a passing test. Now, my thought here is there a way, like, can I do this or something? Is that a thing that is valid? Huh, yeah, okay. So I can define methods in there. So my thought here, we can write tests. I'm going to make my virtual machine, every time you step, return a new instance of the virtual machine that has the state updated to be whatever makes sense. So this next method is just always going to return, machine.new with new values. And that way I can write some really easy tests. And honestly, this is just a fun way to write code. I don't need to write it this way, but let's have fun. We're here to have fun. And this is a pattern that's like legitimately useful, like creating these kinds of mutable objects. The reason I use struct, I guess I should explain, is because structs are, they implement equality so that I can write the test I'm about to write, honestly. Let's just see the test I'm going to write. Test nop. Test nop. So I can say machine equals new, and then I need to give it a program, and the program is going to just be nop 0, nop 0, nop 0, and the pointer is going to be at 0. It's the index into the program, and the accumulator does not matter, so it'll also be 0. And then I can assert equal machine.new. Actually, so let's program equals so equal machine.new program 10 machine.next. This immutable thing that I've just done is actually, this actually does make this, is going to make this implementation easier, I think. So we've got a failing test. Fails because we were returning nil. So we can make this test pass pretty easily. We say machine.new, then we just pass in the program, pointer +1, and the accumulator. And we've implemented our first instruction, the only instruction we now support. So let's test this. And for the sake of so now we can say it's we expect to have that and that in there. Current instruction is program pointer And we can memoize that. So like these machines are immutable. So for each one, the current instruction is never going to change. It's going to return a new one with oops, what programming language am I writing? Let's just use an if statement. I don't care. You have to put an end? I guess you probably do. Good syntax. Cool. Okay, so that's another another thing implemented, and then we're finally going to do jump. So let's take this and replace this with a jump -2 and next to be 0 and just leave an accumulator value in there. So test jump doesn't work. We can now implement jump, which is pointer a minus current. Instruction.last, and I regret calling this current instruction. I just want to call it instruction. Too long a variable for puzzle solution, you know? Oh. Okay, so we have working VM that implements our instructions, and now we just need to implement the solution. So yeah, this is boilerplate that I've just been doing every day. I should probably fix that. Is my apple cider a drinkable temperature yet? Yes, it is. Sorry if I just drinking ASMR to everyone. All right, so we got a working machine. Machine.new. Input is our program. Start at the beginning with an accumulator of 0. While states, while not states dot include machine, machine equals machine next. States machine, and then machine dot accumulator. Okay, so that passed all our tests and is running now. It is not fast, as we can see. It is really slow. Okay, we can optimize this. But I'm worried that this is so slow that I've made a mistake. That also passes. Oh. My chat just... Oh, I know. I navigated away and back. This is taking quite a long time. Oh, I'm wrong. I see. So, that's funny. So this worked, but I did the wrong thing here because I don't care about tracking the current state of the machine in its entirety. I only care about the current state of the machine's counter, right? So let's go say pointers. I mean, I guess we can just do it the way we did before. Stage dot machine dot pointer and dot pointer and pointer. Okay, there we go. So the machine was in an infinite loop, but it was never ending up in the same state multiple times exactly, just on the same instruction. Okay, perfect. So that actually worked pretty well. Let's commit part one. Part one complete. My Git history is just garbage. It's usually Git history for me in these things is just a big save button. After some careful analysis, you believe that exactly one instruction is corrupted. Somewhere in the program, either a jump is supposed to be a NOP or a NOP is supposed to be a jump. No ACK instructions were harmed in the corruption of this boot code. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. By changing exactly one jump or NOP, you can repair the boot code and make it terminate correctly. For example, consider this code. If you change the first instruction from a NOP to a jump 0, it would create a single instruction infinite loop, never leaving that instruction. If you change almost any of the jump instructions, the program will still eventually find another jump instruction and loop forever. However, if you change the second to last instruction from a jump -4 to a no op -4, the program terminates. The instructions are visited in this order. Sure, cool. I guess this is going to be our test input. After the last instruction, the program terminates by attempting to run the instruction below the last instruction of the file. This change after the program terminates. With this change, after the program terminates, the accumulator contains the value, 8. After the program, fix the program so that it terminates normally by changing exactly one jump to a NOP or NOP to a jump. What is the value of the accumulator after the program terminates? Okay, so we can write a test for that, and I think that's not too hard to do. Running part 2. Nice. So this is a tricky one. This is tricky. I was oversimplifying it in my head when I was thinking about how this would be relatively easy. Good thing we've got apple cider. Okay. I mean, we can. We could do this. We could even do this with concurrency if we really wanted. But what's the easiest way to actually code this? Let's just copy our original solution because it's going to look kind of similar, at least the setup and the teardown here. Very different whiskey than yesterday, though. I guess 20% alcohol difference or whatever will do that. Okay, for starters, I'm going to expose the instruction method on my machine so that I can inspect it from the outside so that I can manipulate the running of this machine. Now, we have a bit of conditional logic to write, I think. So, if we might even use recursion. No, I want to use a loop, don't I? Wow. This is tricky. So, the lights are about to change in here. So we set up the machine, and then we want to say for each step, recursion probably is the way. As long as it fits in the stack space, I want to do recursion. Don't exactly know where I'm going, but we'll see if I get there. That's why I'm being quiet. I am thinking. So so we have a few conditions. I think this is going to be an else if. So if machine dot pointer is equal to machine dot program dot length, then we're done. That's our base case. And we should just return that machine. So like our solution is actually just like that. However, if there's some more stuff that need to do, but I think we're somewhere vaguely stepping towards a solution. I don't know if it's a good one. And then we need to know so I'm going to at states machine first thing we'll do, we'll say machine dot pointer is true. So that records that we have seen this state. Okay, so we actually have a top level conditional. If at states have I considered an instruction being revisited? I don't think if an instruction gets revisited, then we're in an infinite loop because we're not using the accumulator state for anything. There's only one path through a program, right? What are you getting at? Cool. So we'll return nil if we've been to the state before. Otherwise, we will mark the state as having been visited, and then if we are in our final state base case, we will return the machine. Otherwise, we will return either the universe, the result from the universe where we don't swap the program, or I need to figure out how to use Ruby arrays. So I need to return an array with a single element replaced. I don't actually know of a good way to do that. Change the contents of self with the contents of other array, truncating, expand. That is not what I need. Or if there's a good way to do this. don't want to mutate the program. That is sensible. Thank you, Hoth. That is the way to do it. Or just gonna use a block here. It's not pretty, but it'll work. Program equals machine.program.dupe program machine.pointer. My memoization might hurt me here. That is fine though. Oh no, it's fine. I'm just going to construct a new one right here. Program equals oof, come on, brain. Machine dot instruction dot last, and then I'm just going to inline that. So that's gonna do my flip. I feel like that's a funny way to do that, but I like it. And then we will step a new machine with our new program, but the same pointer and the same accumulator, though accumulator's still not doing anything. Probably written some kind of infinite loop. Accumulator. It's being used somewhere. Oh, undefined accumulator on line 127. Okay, so I was just not reading. Okay, so this tells me that I've done something wrong because we are getting nil at the end of this thing. We should only be returning or maybe maybe I see what you're saying, Hoth, because we're changing the program. Does that mean that we can't? It doesn't matter whether whether we've hit that thing in any universe. So maybe the visited states should be part of the machine implementation. It's hard for me to test whether that's the mistake I'm making. But it's easy for me to test whether this apple cider is delicious. It is. So, I'm going to talk through this. At each step, we give up if we have seen the current instruction before. If we haven't seen it before, then we continue. mark that state as having been seen, that instruction as having been seen. Then if we have found our solution, we return it. Our end state, we return it. Otherwise, if we've encountered a no-op or a jump, we test whether from that point we can reach a valid end state. If we can't, if we hit a duplicate instruction, we back up and instead replace the current instruction with a jump or a no-op as appropriate. Then we attempt to execute that. I mean, that sounds sensible. And if it's just an ACC instruction, we just continue. This sounds sensible to me. When I say it out loud, the only thing that seems iffy is my tracking of the states we've seen. And Hoth said something about that, so it makes me think I might be missing something. Well, I guess we move the tracking to the yeah. Okay. So we can move this logic into our machine so that each machine can test the instructions that it, or record the instructions. Wow, that's all right. I think I can personally attest to the fact that many people have asked me questions while programming that did not know the nature of the bug I was encountering and still should deserve credit for helping me solve it, or potentially more credit than myself. So I've certainly worked with even non-technical people who are extraordinarily good at asking questions. They're like that just sort of prompted me to solve the problem. It was quite. Some people are good at that. Some people just get lucky. So we need to record previous pointers. All right, so this is going to break everything. So first, let's pass it in everywhere, and then try and get these tests passing. So so this is going to need 0. This is going to need 1, and this is going to need 2. So that's perfect. I guess I should stop. For the purposes of getting rid of that error, I am just going to return 0 right here. Okay. And prove pointers plus pointer. Okay. And we've broken our part 1. Just because of that, I think. Okay. Now I want to test loop. What does it do when it loops? Just returns nil. I think we can work with that because we'll still have the reference to the previous machine. Program. So the simplest program we could do would be jump -1. We start at this, and we would expect machine.next.next. Is there an assert nil? Is that a thing we have? Okay. If it's not technically efficient, but that is not working. So we execute this instruction, then we execute this instruction, and we should see this instruction again. Ah. So that's probably gonna work, right? Yes. But I guess we're 2 steps beyond where we need to be at this point, right? So maybe that's not the best way to do that. Maybe I thought about that API too hard, but what error? Unified method pointer for nil class in that's in part 1 test. Okay, so our part 1 needs updating. Why don't let's keep part 1 running. We no longer keep track of states. While Excuse me. Just do loop. Loop do. Next. Next machine equals machine. Next. If return machine dot accumulator if next machine is null. Otherwise, I could have written this better, but next machine. Okay, so that has worked. I'm just going to commit that as refactoring. Now, back on to part 2. No longer need to keep track of states. No longer need to return 0. You no longer need to do this stuff. All of the returning nil has been handled for us, and we are not setting up the machine with a thing. And we're hitting an error on line 135. We are still getting nil results. Okay, I think I tried to overthink this with this recursive function. Because I can iterate over all the possibilities of this program. I don't need to do this like crazy recursive thing. What am I doing? Like I can use recursion to like find whether the thing. Okay. So let's tackle that. This is one of those moments where you get into a problem, you go for a solution. Now looking back at it, there was a much easier way to do it, but let's do it. What's the easiest way to iterate over all of those? So I want to have a I'm going to call this method compute. So that, given an arbitrary machine, will either will recursively tell me whether it succeeds. It'll either give me the final program state or it'll return nil, I think. And now we just need to run that for every possible solution until we find one. So if we say input this could be interesting, but we'll get there. So each with index.select do, then we'll take how do I do this? Oof. That's my time. 9:57. Oh no, okay, I gotta get hurrying up. Input each with the index. So I need to find all of the indexes that contain either an accumulator or a jump instruction. Probably. That seems useful to do anyway. Instruction, index. Right, so this is gonna give me this, then I have an instruction, an index. Cool. So we'll pry, get out of there. So, if instruction.first jump. I guess that's what I want. Cool. So we're going to say input.dupe input.dupe program index equals same thing I did before. Oh, man. Oh, struggling. Index first. And program index last. If return machine accumulator if machine no implicit conversion of symbol into integer. Line 137. I somehow wrote symbols for all of these. Yeah, I think the 1 rather than 2 ounces of bourbon in the cider was a good call earlier. And that was probably the solution that I just looked away from. Excellent. There we go. Just over the hour. Got hung up on a bad assumption I made. That happens. Unfortunate, but we got there. I really enjoyed the sort of like building my machine as like an immutable thing. Surprisingly helpful in this one, I think. Though I certainly could have done it without it. Thank you everyone for coming. Follow me on Twitter, SuperGoodJared. If you're looking for some help with your Rails-based e-commerce, give us a shout at Supergood Software. And I will see you all tomorrow night for day 9.